Hi, today let's do this question on LeetCode. Question number 84, largest rectangle in histogram. So we are given n non-negative integers representing a histogram. For example, given S, we are having a histogram like this. And we want to find the area of the largest rectangle in the histogram. And for the given example, the correct answer should be this one. This rectangular in the shadow, and the area should be 2 times 5, which is 10. And for this question, a naive solution would obviously be brute force, and we can just brute force the left edge and the right edge of the rectangular and find the height of it and get the area and compare all the areas, right? But it's very inefficient. A better way, but not a best way, is to go through all the possible height. And for the given example, there's only 6 possible height. For example, if the height is 2, the first 2, the rectangular will only be the 2 itself. But if the possible height is 1, then the width of the rectangular can be as big as 6, right? If the height is 1 and then the width is 6, the rectangular area will be just a 6, right? But if the height of the rectangle is 5, then we can get the answer, the answer rectangular, which is 2 times 5. So by going through all the possible height, we can just find the right edge and the left edge for all the heights, for all the numbers in the given array. Okay? And there is an efficient way to do that. And the correct way is just using monotonic stack. And let's see how we do it. First of all, we need to have a stack. And in the stack, we are maintaining an increasing subsequence of the given array. And we are going to store the indexes of the numbers. And we should also have an answer and initiates it with 0. And for all the possible area of the rectangulars, we just compare it with it and update it with the maximum of the areas, okay? And then we go through the right edge of the rectangulars. For right, in range, length of heights. Right? So, if the height of the right edge is bigger, we will just directly append it or push it into the stack. But otherwise, we need to pop out the top of the stack. So, while the length of the stack is bigger than 1, because the first one is minus 1, that's meaningless, right? And the coming height of the right edge is equal or smaller than the top of the stack. Then we have to pop it out. And we have to use that, the one that has just been popped out, as the height of the rectangular. Okay. And what is the left edge of the rectangular? It is just the top that is remaining in the stack. Why? Because it is a monotonic stack. All the numbers increasing from the bottom of the stack to the top of the stack. And we know after we pop up the top of the stack, the remaining top will be the one that is smaller than the one that is just being popped out. For example, if we have a 156, okay, 156 in a stack. After we pop out 6 out of the stack, and the top will be just a 5, and the 5 will be the left edge of the rectangular that's using 6 as the height, right? And we can update the answer. Height times right minus left minus 1, because both right edge and the left edge are exclusive edges of the rectangular. They are not the real edges. Okay, so for example, for the given array, the rectangular in the shadow will have 1 and 2 as the exclusive edge, right? And after that, we just append the right edge into the stack, right? Because all the values that is equal or bigger than the current one has been popped out. Okay. Are we done? No, because after doing this for loop, all the values has been pushed in the stack, but only some of them has been popped out. And there are still some remaining ones that is stored in the stack. And we have to pop them out also. And for all the values that is remaining in the stack, the right edge of the rectangular will be just the length of the heights of the array itself. Okay, and while the length of a stack is bigger than 1, because we know there is a -1, a -1, right? And for this one, we have to have h basically do the same thing, right? And we can just directly copy. And then we can just return the answer. Let's try if it works. And seems it is. And let's submit. Okay, thanks for watching.